Right now, in the vacuum between your atoms and the vast reaches of the cosmos, there is a fundamental speed limit to reality. We assume that space is a continuous, unbreakable fabric, the stage upon which the universe performs. But what if that stage isn't solid? What if the fabric of space-time can rip, fray, and dissolve into nothingness? At the edge of a black hole, space isn't just curved, it is being torn apart. And if that tear happens, every law of physics we know doesn't just bend, it ceases to exist. Welcome to Deep Science Explained. We spend our lives worrying about the things within space, asteroids, solar flares, the passage of time. But we rarely stop to ask what space itself is made of. In this journey, we are going to explore the most violent phenomenon in the known universe, the literal tearing of the space-time manifold. By the end of this video, you will understand how modern physics in 2026 has moved past Einstein to a terrifying new reality, a universe where space is not a place, but a substance that can break. We will look at the Big Rip, the quantum foam that bubbles at the smallest scales, and the mathematical proof that our reality might be nothing more than a temporary patch on a much darker void. This changes everything you think you know about your world, your future, and the very ground, or lack thereof, beneath your feet. To understand a tear, we first have to understand the cloth. Einstein gave us the image of space-time as a trampoline, a flexible sheet that dips under the weight of stars and planets. This is science explained at its most elegant. We've been told for a century that space is smooth, infinite, and perfectly elastic. But here's where it gets even stranger. If you stretch a trampoline too far, it doesn't just keep stretching. It reaches a breaking point. In deep science, we call this the singularity. At the center of a black hole, the curvature of space becomes infinite. Think about that for a second. Infinite. In mathematics, infinity is often a sign that the equation has broken. In reality, it means the fabric has reached its limit. This is the part nobody tells you. Space is not nothing. It has properties. It has a tension. And just like a piece of silk being pulled by two teams of horses, space-time has a threshold where it can no longer support the weight of gravity. When a star collapses into a black hole, it isn't just falling into a hole. It is punching a hole out of the universe. It is a puncture wound in reality. But here's where it gets crazy. You don't need a black hole to tear space. You just need enough time. Enter dark energy. Right now, the universe is expanding, not just growing, but accelerating. Every galaxy is moving away from every other galaxy faster and faster. If this acceleration continues to increase, a theory known as the Big Rip, the expansion will eventually overcome every force holding the world together. First, galaxies will be torn apart, then solar systems, then stars. But this is the part that breaks your brain. Eventually, the expansion becomes so violent that it tries to expand space itself faster than space can hold together. Imagine trying to inflate a balloon, but the rubber can't stretch fast enough. The balloon doesn't just get bigger, it disintegrates. This is the ultimate cosmic mystery. Space-time would literally fray. Atoms would be ripped from the inside out because the space between the nucleus and the electrons is expanding so fast that the electromagnetic force can't bridge the gap. If this is true, then space isn't just the stage, it's the victim. What would it mean if the very emptiness of your room was trying to tear itself away from you? How would your life change if you knew the universe had an expiration date written into the vacuum itself? If we zoom in, past the atoms, past the quarks, down to the Planck length, the smallest possible distance in the universe, everything we know about smooth space vanishes. This is mind-bending science at the quantum level. In 2026, physicists are exploring the quantum foam, At this scale, space is not a flat sheet. It is a violent, bubbling sea of energy. Tiny tears are forming and healing a trillion times every second. These are called virtual wormholes.
But here's where it gets crazy. If we could freeze one of these micro tears, we would find a region where time doesn't exist. Space is so broken at this level that before and after lose their meaning.
This is the physics explained that nobody mentions in school. You are currently sitting on a sea of microscopic holes in reality. If space can tear at the bottom, why do we assume it's solid at the top? Every time you move your hand through the air, you are essentially wading through a foam of broken space-time. This is the part nobody tells you. The solid world is an illusion created by our inability to see the holes. When space tears, what happens to the stuff inside it? This is the core of the mystery of the universe. If you fall into a tear, into a singularity, physics tells us your information must be preserved. But a tear, by definition, is an end. Imagine a digital file on a hard drive. If you physically cut the drive in half with a pair of scissors, the data at the cut is gone. If space-time is the hard drive of the universe, and it tears, does the data of your existence simply delete? Stephen Hawking spent his life fighting this idea. He proposed that tears aren't permanent, they leak. But this is where everything breaks. If space can leak, it means space is a fluid. And if it's a fluid, it has atoms of its own. We call these atoms of space. If space is made of parts, it can be disassembled. We are beginning to realize that the universe might be a self-healing fabric, but every time a black hole forms, a new thread is pulled. How many threads can we lose before the whole tapestry unravels? What is on the other side of a tear in space? To answer this, we have to look at the deep science of non-locality. If space-time is a fabric, there must be something it is on. Many modern theories suggest that space is an emergent property, like the surface of a pool. Beneath the surface is the water, but the surface itself can be broken. On the other side of a space-time tear isn't more space. It is a state of pre-geometry. No distance, no time, no here or there. This is the most counterintuitive idea in physics explained. A tear in space doesn't lead to a new room. It leads to the absence of rooms. It is a return to the state before the Big Bang. Every black hole is a tiny undo button for the universe. So here is the reveal. The mystery we started with, the idea that space can tear, isn't just a threat. It is the reason we exist. In 2026, a revolutionary theory is gaining ground. Space-time must tear for the universe to evolve. If the fabric was unbreakable, the Big Bang could never have happened. The universe began as a puncture in nothingness. Gravity is simply the name we give to the tension of the fabric as it tries not to rip. This changes everything. You aren't living in a space, you are living on a tension. Your mass, your weight, your very life is a result of the fabric of space-time resisting a tear. If the tear finally wins, it isn't a catastrophe, it's a reset. This gives us a goosebumps moment of cosmic perspective. We feel so significant, so permanent, but we are actually just the ripples on a cloth that is being pulled tight across an infinite void. We are the patterns of the weave. The fact that space can tear proves that space is a thing, and that thing was crafted, born, and will eventually be recycled. You aren't small because the universe is big. You are amazing because you are a part of a fabric that can survive being torn apart and still produce you. Space tearing apart isn't the end of the story. It's just the moment we see the machinery under the floorboards. We are the only species on this planet that has ever looked at the void and tried to measure it. And if you think a tear in space is terrifying, Wait until you see what happens when we apply this to the tearing of time itself. What happens when the sequence of cause and effect begins to fray? Tell me in the comments, which part of this video broke your brain the most? Was it the idea that you're sitting on quantum foam, or the possibility of the Big Rip deleting the stars? I read every comment, and I want to know your theory on what's on the other side of the tear. Make sure to subscribe to Deep Science Explained to keep exploring the edges of reality. The fabric is thin. Let's keep looking through the holes.